Welcome all. This is a simple example. X takes two values 1 and 2, Y takes two values 1 and 2. And the probabilities are given here 2, 0.4, 0.1, 0.3. And from that we have to find marginal distribution of X. Okay. Got it? Marginal distribution of X. Right? You have to add. You are summing all those probabilities where X is constant at X. It could be anything like suppose X is 1 here. Probability of X is 1. That will be equal to summation probability X is 1. For all values of y, you are summing over values of y, right? That means here 0.3 is probability x1, y1 plus probability x1, y2. 0.2 plus 0.1, that is 0.3, right? Similar to this, if you see in continuous distribution also, we just replaced the summation by integration sign. Yeah. And over y is here, over y is here. And the probability mass function we have written here, or probability function, here we have density function. That is the only difference. So when you integrate fxy with respect to y, keeping x constant, you have to integrate this one, 2x. Integration 2x is constant because x constant. So 2x you keep as it is, and dy integration y. The second one y dy, y square upon 2, minus 5 to 5 in y, because you are integrating with respect to y. So when you replace y by 5 and minus 5, you will get this, and finally x will be there. This will be a function of x. No, this anyway I'll send you, right?
Okay, perfect, fine.
And the document also I'll send you.
Okay.
Yeah, so x upon 150. Okay. If you compare this one and this one, if you compare this side and this side, the left hand side is the discrete one and the right hand side is the continuous one, right? And here point wise you get, suppose you are finding probability x1, probability x2. If I go down a bit, if you see here, we have probability x2 as well, right? Probability x2. Here, probability x1, probability x2, we are getting individually, right? In the right hand side, we have fx. Okay. So, because it's continuous, for all values, you have to put in x upon 150. You will get individually. If you see fx we have written here in a tabular form. The tabular form is already written here under this arrow. And in the right hand side, here, the tabular form will be this one. Now, if xo is given, the joint distribution is given, can you find expected value of x? Yeah, now we have fx. You can find expected of x, right? Are you able to see f of x properly? I'll take maybe from where it's coming. Maybe this is from the PDF. Now, fx is x upon 150, x is between 10 to 20. This is fx. From here, you can find expected value of x. That will be x f of x dx. Sorry. X f of x dx integration between 10 to 20. So, if you want to find expected value of x from the left hand side, you know how to find. It's a discrete distribution. This is a continuous distribution. That is the only difference. Yeah. You ask something? Yeah, you have to integrate, right? You need to integrate x square upon 150, x square integration x cube by 3, right? X power 3 divided by 3. So, yeah, how to find marginal distribution of x? This was the question. Okay. Now you can find marginal distribution of y. Yeah, keeping x constant, right? So how can you check whether this is independent or not? I mean, x and y are independent or not? Total must be equal to product of marginals, right? The condition, last time we discussed fxy, the joint distribution must be equal to fx multiplied by fy. So for that you need to find fy. But before finding fy, without finding fy, can you decide whether that is independent or not? Yeah, see, it's possible, because if you see the question here, can you get 2x plus y after multiplying something? Can you get 2x plus y if you multiply a function of x and a function of y? If you take x multiplied by y, maybe you will get, but 2x plus y, I don't think you will get it. So even if you find now fy and multiply, would you like to find fy? Okay, do fy. I'm giving you 5 minutes. Instead of talking, it's better. One you can do. Done? Actually, it was not done here. So we can try combine. You need to integrate 2x with respect to x, right? That is x square. So x square plus xy is what you will get it. And between 10 to 20. X square plus xy, you have to replace x. Yeah. So 300 you will get. Okay, 300 divided by 3000 anyway, that's there. That will be 1 upon 10, right? Yeah, then we have xy also, right? Got it? I got it. You write 20 square minus, you replace by 20x, then that you
Get
multiply.
20y.
Okay, whatever expression you got, that's fine.
Yeah, I got 30
Multiply
minus
that
y by
one
3.
with fx. Can you get fx right? That is the question. No, right? Because there is a plus sign here. Yeah, that is the reason. There is a plus sign. By multiplying two expressions separately, one is a function of x, one is a function of y, you can get a plus sign here.
Understood.
That's why without doing also you can say not independent. Okay. This is one question we will not do now. Can you do? X and y continuous random variables. I think this is question from SO. Joint density function fxy given. Let g be the marginal density function of y. Which of the following represent g? First of all, you tell me what is the difference between this problem and the one we solved just now. The difference is here the limits. Limits are not given. You have to find limits. For that you need double integration knowledge. Okay. That might create problem. You have to draw two graphs, y is equal to x, y is equal to x square and all that. So that's why we'll go to this one later.